بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Today we will talk about the domain of definition and the range of a function. Domain of definition of a function, algebraical approach. The domain of definition of a function is the set of all possible x values so that f of x exists. To find the domain of definition of a function defined explicitly or algebraically, remember the denominator of the function should never be 0 and the number under a square root sign must always be positive. Now let's take an example. The question is to find the domain of definition of the function f. In this case, the domain is the set of all real numbers because we don't have x in the denominator and we don't have any square root sign. Well, in this case, we have to state that x squared minus 9 should never be 0, so x is never 3 and x is never negative 3. So the domain of definition is negative infinity, negative 3 union, negative 3, 3 union, 3, positive infinity. Now, in this case, x minus 2 should always be positive, so x is greater than or equal to 2 and the domain is 2 closed plus infinity. And finally this one. In this case, 4 minus 2x should be strictly positive because 4 minus 2x is under the square root sign and it is in the denominator. So we get x is smaller than 2 or the domain is negative infinity 2 open. Now try to do this application, please. Now let's see this one. F in this case is defined for this quantity to be positive. Remember, to solve an inequality as usual, we compare to 0, factorize as much as possible, we find the roots, we construct a sign table, and then we find the result. So in this case, if we factorize, we get x into x squared minus 1 over this quantity. The roots are 0, 1, negative 1, and x is never minus 3, and this factor has no roots. We construct the sign table, and we get the result. We need it to be greater than or equal to 0, so we have to choose negative infinity, negative 3, union, negative 3, negative 1, union, 0, 1, and it should be closed at both boundaries of 0, 1. Now the domain of definition of a function, graphical approach. Well, to find the domain of definition of a function defined graphically, we project orthogonally all the points of C on the x-axis, and we find the set of all the projected points which represents the domain of definition. Let's see what we mean by these two steps. Now we have a curve that represents a function f, and we need to find the domain of definition of f. This is the curve. So, to find the domain of definition, we project all the points on the x-axis. And then, this would be the domain of definition. The blue part would represent the domain of definition, which is, in this specific case, the set of all real numbers. Now, let's take another example. Well, in this case, if we project on the x-axis, we project each point of the curve on the x-axis, we see that we're going to have a gap here because we don't have any curve up and or down. So the domain of definition in this case would be these two branches, or it's negative infinity 1 union 4 plus infinity. Please remember the closed circle at point A, which is here, means that A belongs to the curve, and the open circle at point B means that B doesn't belong to the curve. So the domain of definition would be closed at 4 and opened at 7. Now we need to find the domain of definition of a function defined graphically also, and this function is called G. Now let's go on talking about the range of a function graphical approach. To find the range or the image of the domain of definition of a function defined graphically, we apply the following two steps. First, we project orthogonally all the points of C on the y-axis in this case, and then we find the set of all projected points which represents the range. We have a given curve of a function f, and we need to find the range of f for the image of the domain of definition. Well, this is the curve that represents f. Project it on the y-axis, and if we project all the points of the curve on the y-axis, we're going to get this blue part. This is the range of f, which is represented by the open interval 1, positive infinity. So it varies from 1 to positive infinity. Let's take another example. This curve, if we project it on the y-axis, you see, this is the range, and this is also the range, and in this case the range would be closed at 0, opened at positive infinity. And notice here that in case of the range, the intervals might overlap. So notice here that the difference between the domain and the range is that the domain is the set of projected points on the x-axis, whereas the range is the set of projected points on the y-axis. Now determine the range of the function g. Okay, Rima or Amir or Rami, we need to draw a curve of a function whose range is negative infinity 3 opened. Rima drew this curve. Amir drew this curve. And Mira drew this curve. Remember, the question is, we need to draw a curve whose range is negative infinity 3. Now, which curve is correct and which curve is not correct? Let's begin with Mira. Mira didn't draw the curve of a function. Pay attention, so this is not correct because this is not a function. To be a function means that if we draw a parallel to the y-axis, should cut the curve in at most one point. Okay, now let's see the first one. In fact, in the first one, the domain of definition is, if we project on the x-axis, the domain of definition is from negative infinity to 3 opened, whereas the range, if we project on the y-axis, the range would be from negative 1 open to plus infinity. So this is not correct. And if we go to Amir, we can see that the domain of definition in this case is from negative infinity to positive infinity, the set of all real numbers, whereas the range is from negative infinity to 3 open. So Amir is correct. Thank you.